Welcome to this lesson on target groups, a fundamental concept in AWS networking. Target groups are essential components that enable load balancers to distribute traffic efficiently to your backend instances. Throughout this lesson, we'll explore what target groups are, how they work, and why they're critical for building scalable and resilient applications on AWS. A target group is a logical grouping of resources that receive traffic from a load balancer. Think of it as a collection of servers or services that can handle incoming requests. Target groups serve three primary purposes. First, they group backend instances together, making it easier to manage multiple resources as a single unit. Second, they route traffic based on specific rules that you define. And third, they continuously monitor the health of each target to ensure traffic is only sent to healthy, available resources. AWS supports 4 different target types, giving you flexibility in how you architect your applications. The first type is instance, which allows you to route traffic directly to EC2 instances using their instance IDs. The second type is IP address, which enables routing to specific IP addresses, whether they're inside your VPC or even on premises in your data center. The third type is Lambda, which routes requests to AWS Lambda functions for serverless processing. And finally, you can use another application load balancer as a target, enabling advanced multi-tier architectures. Let's understand the flow of traffic through target groups. The process begins when a load balancer receives incoming traffic from clients. The load balancer then forwards this traffic to a target group based on configured routing rules. Finally, the target group distributes the requests among its registered targets, which are the actual servers or services that process the requests. This architecture provides a clean separation between traffic distribution and request processing, making your applications more maintainable and scalable. When configuring a target group, there are 4 key settings you need to understand. First is protocol and port, which defines how traffic is forwarded to your targets. You can choose from HTTP, HTTPS for web traffic, or TCP and UDP for lower-level network traffic. Second is health checks, which monitor target availability with periodic checks to ensure traffic only goes to healthy instances. Third is the load balancing algorithm, where you can choose between round robin, which distributes requests evenly, or least outstanding requests, which sends traffic to the target with the fewest active connections. And fourth is stickiness, also known as session affinity, which routes a user's sessions to the same target, ensuring consistency for stateful applications. Health checks are crucial for maintaining application availability. Let's look at the key parameters you can configure. The health check path is the specific endpoint that the load balancer tests, such as /health. The interval defines the time between consecutive checks, ranging from 5 to 300 seconds. Timeout specifies how long to wait for a response, between 2 and 120 seconds. The healthy threshold is the number of consecutive successful checks needed before marking a target as healthy. The unhealthy threshold is the number of consecutive failures before marking a target as unhealthy. And success codes define the expected HTTP response codes, typically 200 to 299, that indicate a healthy target. Different load balancer types work with target groups in specific ways. The application load balancer, or ALB, operates at layer 7 and handles HTTP and HTTPS traffic. It supports advanced features like path-based routing, where different URL paths go to different target groups, and host-based routing, where different domains route to different targets. The network load balancer, or NLB, operates at layer 4 and handles TCP and UDP traffic. It's designed for ultra-high performance scenarios and supports static IP addresses. Finally, the gateway load balancer, or GWLB, operates at layer 3 and is specifically designed for deploying network appliances like firewalls and intrusion detection systems. It uses the GENEV protocol for traffic encapsulation and supports security inspection workflows. Let's recap the essential concepts about target groups. First, target groups organize backend resources for load balancers, providing a logical grouping that simplifies management. Second, they support multiple target types including instances, IP addresses, Lambda functions, and even other application load balancers, giving you architectural flexibility. Third, health checks ensure traffic only routes to healthy targets, preventing requests from being sent to failed or unavailable resources. And fourth, target groups work seamlessly with application load balancers, network load balancers, and gateway load balancers, each serving different use cases and traffic patterns. Understanding these concepts is fundamental to building reliable and scalable applications on AWS.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.